What if one of the brightest stars in the night sky holds secrets about the future of our own sun? Arcturus, a massive red giant, is 100 times brighter than the sun and 25 times its size, but its fate is a glimpse into our solar system's distant future. This cosmic giant may one day create a breathtaking nebula, leaving behind a tiny white dwarf. Want to know how it got here and what makes it so extraordinary? Arcturus is a magnificent star, one of the brightest in the night sky and among the closest giants to our solar system. It resides in the constellation of Bootes. Arcturus holds deep significance across various cultures. Its name derives from Greek, meaning guardian of the bear, or guardian of the Great Bear, due to its proximity to the Ursa Major constellation. Out of the thousands of stars visible to the naked eye from Earth, Arcturus stands as the fourth brightest, a true gem in the celestial expanse. The way we measure a star's brightness today traces back to the ancient Greek astronomer Hipparchus, a mathematician, engineer, and cartographer from the Alexandrian school. Nearly 2,200 years ago, Hipparchus developed the concept of magnitude, a system to rank stars by their apparent brightness. He classified stars visible to the naked eye into 6 magnitudes, with lower numbers indicating brighter stars. Stars with an apparent magnitude of 6.5 or higher are not visible to the unaided human eye. Now, let's take a journey to Arcturus. Arcturus is located 36 light-years from Earth, making it a close neighbor on astronomical scales. Even so, with our current technology, the journey to this star would take nearly 650,000 years. Arcturus is easily visible from Earth due to its incredible brightness. However, from the region around Arcturus, our sun would appear as a faint point of light, barely distinguishable. Arcturus is a red giant star. A star's color depends on its surface temperature. Blue stars are the hottest and brightest, while red stars are cooler. This is why most visible stars in the sky appear blue. Arcturus has a surface temperature of about 4,000 degrees Celsius, slightly cooler than the sun's 5,500 degrees Celsius. Despite being cooler, it shines brilliantly due to its enormous size. Its vast surface area generates the intense light that makes it stand out in the galaxy. Arcturus is 100 times more luminous than the sun. Its diameter reaches an astonishing 35 million kilometers, 25 times larger than the sun's diameter and nearly 3,000 times the diameter of Earth. Arcturus has low density, with little matter spread over a massive volume. Even though it is enormous, its mass is nearly the same as the sun's. Arcturus is in the late stages of stellar evolution and wasn't always a giant. The star is approximately 8 billion years old and was once similar in size to the sun. Stars spend most of their time in the main sequence phase, where they fuse hydrogen atoms into helium in their stellar cores, regions that reach around 15 million degrees Celsius. Hydrogen is the most abundant element, making up about 90% of all atoms in the universe, and stars are primarily composed of this element. The brightness and stability of a star result from the fusion of atoms at its core, balanced by gravitational force. Gravity constantly pulls the star inward toward its core, causing atoms to collide at extremely high speeds and fuse together. The star isn't crushed by gravity because the immense energy released during fusion pushes outward, balancing the gravitational pressure. After billions of years, when the hydrogen is depleted, the star begins to fuse helium. However, helium fusion is less efficient since the element is heavier and requires more energy to fuse. With less efficiency in releasing energy, gravity exerts greater pressure, compressing the core and increasing its temperature, causing the outer layers to expand many times their original size. This will also be the fate of the Sun. In about 5 billion years, our star will undergo the same process as Arcturus, expanding several times its size and engulfing planets from Mercury to Jupiter. If Arcturus had planets in close orbit, they were likely swallowed and disintegrated when the star became a red giant. Arcturus allows us to study astroseismology, a branch of astrophysics that examines the oscillations or vibrations of stars. Just as musical instruments produce different tones and frequencies, stars have natural vibrations that can be observed and analyzed. These oscillations provide valuable insights into a star's internal properties, including its structure, dynamics, age, chemical composition, and stage of evolution. The aging Arcturus is nearing the final phase of its stellar evolution. Soon, it will no longer generate energy through nuclear fusion, and its brilliance as a red giant will come to an end. Once Arcturus exhausts its helium supply and can no longer release energy through fusion, it will succumb to gravity and collapse, transforming into a white dwarf, contracting to a size similar to Earth. A white dwarf cannot release energy through fusion or shine like a typical star. At this stage, its glow comes from leftover thermal energy, which will eventually dissipate. As Arcturus sheds its giant layers, the ejected material will form a planetary nebula, enriching the galaxy with elements and creating a cosmic landscape in the night sky. If you enjoyed this journey, don't forget to like and subscribe to the channel for more journeys into space. Consider supporting the channel by becoming a member, sending a thanks to help keep these journeys going. Got a destination in mind? Share it in the comments. Thanks for watching, and see you on the next flight.